Hey YouTube, welcome back. Today we have a new video. Today we have a quick video about event-driven architecture. Today we will talk about what is an event-driven architecture, how it looks like, and what is an actual event and the pros and cons of the event-driven architecture on high level. Because it will be a quick video. So the event-driven architecture is a software design pattern that enables an organization to detect events or important business moments, such as a transaction, site visit, shopping cart, whatever, and act on them in real time or near real time. This pattern replaces the traditional request response architecture where services would have to wait for reply before they could move on to the next task. So how it looks like, it will look like we will have let's just go here. We will have a event producer and let's make it white and make the border white also, and the event producer will produce events to the event broker. Okay, and event broker will send event to subscribers, like called event consumers. So basically it will look like that. The event producer will send event to the event broker. Let me make them white. But let's say it sends to send the event to the event broker, and the event broker will take those events and send them to the event consumer, and we expect the event consumer will return back the results whenever the events been solved, and the event broker will return will just let me delete this one. So event-driven architecture is often referred as asynchronous communication, and this means that the sender or the event consumer and reception, which is the event producer and the event consumer, do not have to wait for each other to move into their next task. Systems here are not dependent on that one message. For instance, a telephone call is considered as asynchronous or more along the lines of traditional request response architecture. Someone calls you and asks you to do something. The requester waits while you respond, the responder completes the task, and then both parties hang up. An asynchronous example would be text messaging. Like, you send a message, and in some cases you don't even know who you are sending it to or if anyone listening, but you are not waiting for a response, like sending emails or something like that. And before I talk what is the pros and cons of this architecture, I want to talk about what is an event. So an event is defined as a change of state of some key business system. For instance, somebody buys a product, someone else check in for a flight, or a bus in late arriving somewhere. And if one thinks about it, events exist everywhere and constantly happening, no matter what industry they are. Prevails across any business. This includes anything that creates a message by being produced, published, detected, or consumed is considered an event. And the pros and cons of event architecture. The pros first, because we have loose coupling. The EDA, which is the event-driven architecture, promotes loose coupling between different components or services. So basically services do not need to be aware of each other existence, but can communicate through events. Basically, the event producer doesn't care about the event consumer doesn't care about the event producer, and the same thing about the from the event producer to the event consumer, because all of them deal with the event broker. We have the scalability. The EDA is inherently scalable. New services or component can be added to handle specified types of events. The flexibility, the EDA allows for flexibility in the system design. You can add new features or services by simply introducing a new event producers and consumers. We have real-time processing. Events can trigger real-time processing and response. This is crucial for application requesting low latency. Decoupling microservices. Decoupled microservice, EDA is well suited for microservices architecture. Each microservice can be independent, consume and produce event. And we have the event sourcing. The EDA is often using in conjunction with event sourcing, where the entire history of event is stored. This enables editing and debugging and monitoring. We have the extensibility. Adding a new functionality or integration becomes more straightforward with the EDA. The cons of the of the event driven. First of all, it's a pretty complex, because if you can think that we have multiple event reason, multiple event consumer, it's a quite complex. EDA can introduce complexity, especially in systems with a large number of events, and event consumers. Debugging and tracing events through a distributed system can be challenging. We have the event ordering. Ensure the correct order of the events can be complex. This is one of the most difficult things. We have the eventual consistency. Event-driven system often prioritize availability and partition tolerance over immediate consistency. We have distributed system challenges, because it's based on distributed system. We have also the message broker scalability. The message broker middleware responsible for routing events can be become scalable, which is this one. We have debugging and tracing. Debugging an event-driven system can be more complex than a request-response system. The request-response system is way more easier than this one. Debugging and we have security concerns, like event-driven have a problem with the security concern. Event-driven system can be vulnerable to security threats like event spoofing or unauthorized event consuming. We can talk about this one as a cons or as a challenges. So yeah, that's it. It was a quick introduction to the event-driven architecture and what is it and what it's look like. And yeah, that's it for this video, and I hope you like my content, and see you in future problems.